Hello, everyone. Welcome back to another episode of Space Club Career Chats. I'm Natasha Wilkerson. I'm the Space Club Director and co-founder of Vivify STEM, and I want to welcome all of our Space Club students and teachers who are watching. What is really crazy, I was just looking at the map of Space Club sites. We now have over 400 schools from 9 different countries that are part of Space Club. And it's been so incredible seeing all of your submissions, from mission patches to rovers to the colony designs. Keep them coming. And at the end of this broadcast, we're going to have a raffle for all the teams that have submitted over the last month. So since our last career chat, we've been collecting all your submissions and they're all in the raffle. So stay until the end and we'll give away a prize. And it's a good one. I also want to remind teams that are in the Space Colony competition. We just closed registration and your submissions are due November 30th. And that is to design a habitat on the moon or Mars. And I'm so excited to see what you guys come up with. But now we are going to go ahead and get started with today's career chat, which is with a special guest, Dr. Lindsay Fuller. So let me tell you a little bit about her. So Dr. Fuller is an astrophysicist at the University of Texas at San Antonio, where she studies the environment around supermassive black holes and distant galaxies. Dr. Fuller received her PhD from UTSA in 2017 and still works there as a faculty scientist. Her research involves data from the Sophia Telescope, an airborne observatory attached to a Boeing 747 aircraft, which is now being decommissioned after 10 years of data collection. She received her bachelor degree in Physics and Astronomy at the University of Texas at Austin, where she was a laser scientist in the physics department. Before her academic career, Dr. Fuller was a translator in the Air Force. She enlisted following her senior year of high school and served in the Air Force for 6 years. All right, let me bring her on. Hello, Dr. Fuller. How are you doing?
Hi, I'm good. How are you?
Good. Well, welcome to Career Chats. It looks like you are joining us from your office. That's
hmm
at UTSA, right?
That is, yeah, in San
And I was
Antonio.
going to ask you, what is behind you? Do you have like a poster of a galaxy?
So,
Pull you
on
up.
this side, so this is a picture of a galaxy that's been observed by Sophia, and so it's unique because this actually maps the magnetic field. So it's not just an image; it actually has magnetic field vectors, and it makes it look really cool. And then over here on my left, this is the McDonald Observatory out in West Texas. And so this is the largest observatory that we have in Texas. And I think this telescope here, the Hobby Telescope, is 8 meters, 8 or 10 meters. I don't remember. But yeah, this is one of our premier, or this is our premier Texas telescope.
Very cool. Well, I'm excited to learn more about your work that you're doing at UTSA, your journey to STEM. And so we had students, these are elementary and middle school kids that have been submitting questions. They read your bio, you have a website, which we'll link below, and this is what they wanted to know. So the first question will start with a team, it's the Guardians of the Milky Way in North Carolina, asked, what made you want to be an astrophysicist?
Cool. Hi, Guardians of the Milky Way from North Carolina. So this is interesting. Like within astronomy, we kind of all say that either you always wanted to do it, like this is something that you wanted to do from the time that you were a little kid, or you took some class and were inspired and thought, I want to, this is something that I really want to pursue. Personally, this is something that I just always wanted to do. So anytime I talk to anyone about astronomy, they always say, "Oh, I love watching the Discovery Channel and the Nature Channel." And so me too. And so when I was a little kid, I really wanted to be an astronaut. And so actually, one of the reasons that I joined the military was because I was looking at astronaut biographies, and I saw that a lot of astronauts had military background, like piloting background and piloting experience. So I started looking into the military. Granted, I did not go the way of being a pilot. I kind of went in the opposite direction, but I still loved my military service. But to answer the question, ultimately, I just always, always, always loved space, and I always wanted to be a scientist or an astronaut from as far back as I can remember.
So there wasn't like a moment where you saw something or something inspired you. It's just like been a constant in your
It's just,
life.
it's always been there. Yeah.
Oh, that's cool. That's cool. And, I've heard that from different people where some are like, this is what I've always wanted to do. And others are like, I saw this documentary, but how did you decide, okay, I love space, but like specifically astrophysicist and like studying now black holes? Did that just kind of happen? Or was that something you're passionate about?
So it kind of came organically. So like I said, I wanted to be an astronaut. I like very seriously wanted to be an astronaut. Joined the Air Force to see like what the Air Force could do as far as like helping me reach that goal. But in the end, I decided against a military approach to kind of being a pilot or whatever it would have taken. And so at the end of my service, I thought, well, instead of being an astronaut, I just really, really, really want to study space. And so that's when I decided to end my enlistment and and then moved to Texas. And I had like a list of colleges. I was like, which college am I going to go to? I lived in Omaha at the time, stationed in Omaha. And so I had a list of colleges, and I decided UT Austin is where I want to go because they had kind of a program that I liked. Now, as far as how did I start studying supermassive black hole, that was by sheer chance.
Really?
I started out like you can see in these photos. Like the first job that I could get when I was an undergrad was as a laser scientist. And so that's what I took. You just say, when you're in a science lab, you just say, yes, I will do that. And that's how you get your foot in the door. So I started out doing laser science. And then when I started looking at grad schools, I talked to a professor here at UTSA who did observational astronomy of the environments around supermassive black holes. And so it just kind of happened that that was kind of the right fit for me for grad school.
That just sounds so cool. Like you tell people, what do you do? Oh, I just study supermassive black holes. What's like the reaction that people have to that?
To be quite honest, the reaction usually is like, oh, I don't know if I can talk to you. And so I usually kind of start slow. I say, oh, I work at UTSA, or I say, I'm an astronomer or something like that. Because a lot of times just saying that I'm an astrophysicist kind of tends to kind of scare people off. And that's not the reaction that I want to have. I want people to say like, oh, tell me more about space. And I'll say, okay, let's talk about space.
Well, let's ask you more questions then. And so this next question is, what was the hardest parts, the hardest stepping stone that got you to where you are now? This is a team in Colorado.
So hi, team in Colorado.
Did Michael?
So I think probably the hardest thing about this is just putting yourself out there and handling rejection, because some people are gonna tell you no. But when I first started an undergrad, the reason that I even got into a lab is because I ended up taking this class on how to use a machine shop, which is in the bottom right corner here in these images. And somebody just said, do you want to learn how to use the machine shop? And I said, sure. I just said yes to everything. So I started working in the machine shop, and then I got a job working in the laser lab. But then even when I was in undergrad, I still wanted to do astronomy. Like lasers wasn't, the passion that I had, even though it's cool, super cool. It wasn't my passion. So I still I went to the astronomy department one time, and I went to one of the premier astrophysicists in the entire UT department. And I was like, can I have a job? And he said yes.
Oh.
Yeah, he said yes. And that was pretty terrifying, because I was like, what am I doing? There's no way that I'm going to get, any kind of job that I want, just cold asking this person who thinks I'm a stranger. But it worked.
Wow.
And so I got a job. Actually, I was calibrating some fiber optics that eventually went on the McDonald Observatory. Wait, that one. So that was pretty terrifying, but I did it. I started undergrad in the first place, which was pretty terrifying for me. But then, I just went, and I had to keep asking people can I work here? Can I work here? And, you have to be able to face rejection, because a lot of people are going to tell you, no, I don't have space for you. What's your background? And when you say, I have no background, you just have to kind of be willing to hear the word no, but keep going anyway,
Yeah, that's such a great message because the worst thing they could say is no. And so
Mhm.
you have to ask because you got a yes, right? And that was a really big yes.
Yeah. And
Um,
I know it's terrifying to hear the word no because you think, well, I'm just not good enough. I'm not good enough is what you tell yourself when you hear the word no. But what you kind of have to like repeat in your head is it's just the opportunity isn't there. It has nothing to do with me. It's just the opportunity.
yeah, I love that. Okay, so now let's talk about the work that you are doing. So, what exactly is an astrophysicist? What do you do?
So, an astrophysicist is someone who studies the environments in space that are outside of our solar system. So, for example, we would study, or astrophysicists study stuff like the interstellar dust, um, the center of the galaxy, stars. What I study is other galaxies. Um, and so essentially anything within the solar system is called space sciences, planetary and space sciences. Astrophysics of everything outside of the solar system. I mean, planetary and space sciences are like super interesting, and the benefit to doing that is you can actually have instruments that go to a planet and you can study this planet with it with you can look at it, whereas for us we have to build these huge telescopes and look out like millions of light years away. For me, I have to look millions of light years away into these distant galaxies. But yeah, so an astrophysicist is somebody who studies the physical processes of stars, star formation, galaxy formation, everything that's outside of our solar system.
And I realize all these questions are from North Carolina. So, hello to Falston Elementary who asked all these questions. Okay, so then you mentioned planetary science or space sciences, astrophysicist, and then astrology is another one that I think gets thrown in and is like confusing to students. So does astrology, how does that connect to astrophysicist and astronomy? Like, can you give
For
us some
sure.
more?
So astronomy is the study of, systems outside, systems in space. But what astrology tries to study is how systems in space affect human beings, or do they affect, I mean, I think the question is, do systems in space affect human beings? I personally don't believe that it affects, a human being's personality or anything like that. But that's what astrology does, is try to tie how do objects, Mars and the moon, how does that affect human biology and physiology?
Interesting. Okay, so then a question for you as an astrophysicist, what is a black hole since that is what you study? How can you describe it?
So this is a great question, and there is a lot of nuance, because essentially what a black hole is it's a dead star. So you have all kinds of sizes of stars that that we see at night. So for really small stars, so actually our moon is kind of an average medium, maybe kind of medium small star. For very small stars, or for any star really, the star lives its life in a state that's called uh, hydrostatic equilibrium, which means that, I know it's a big word, sorry, but what that means is that it's in equilibrium. So outward radiation is counterbalancing inward gravity. And so that's a star just lives its life, processing fuel in the center, and it just radiates. But eventually, that star is going to run out of energy in the middle. And then what happens is that inward gravity, the force of inward gravity is greater than the force of outward radiation. And so gravity takes over, and it just becomes this, core of atoms just sticking together. Now, what happens if you have one really, really big star? And so at the end of the star's life, outward radiation, or inward gravity overcomes outward radiation. And so the star is so big that when it collapses in on itself, the gravity is so great that nothing can, like, no particles, nothing within even an atom can stand up to the inward gravity because it's so massive. So when people say we don't really know what's inside of a black hole, I personally think that's a bit misleading, because what we know is just that the gravity is so great that nothing can hold up against gravity, and so it's just a space of intense gravity.
Is it
And
constantly pulling things toward it?
Not necessarily. So if something is within its orbit, then it'll fall into the black hole. But if you're outside of the orbit, then all you're going to do is just go around the black hole. Or even, if you're far enough away, then there's no like gravitational connection between you and the black hole. But if you're in the vicinity, it just depends on how far back you are. So right now we're circling around a supermassive black hole in the center of our galaxy, but we're not going to fall in. We're way too far away to fall into the black hole.
And what is this a picture of that we're looking at?
So this is kind of what I study. So imagine you can't necessarily see the supermassive black hole at the center, but you can see the environment around it. And you can see this is an artist's rendition of what this looks like. And so what happens is that there is a lot of like gas and dust that gets trapped in the vicinity of some supermassive black holes at the center of galaxies. And then what happens is that all of this gas and dust obscures the very central supermassive black hole. And so this dust that's kind of falling into the supermassive black hole is what I personally study. And then what you see in the blue, this kind of jet. So we all know that nothing can escape a black hole, like not even light itself. But what this jet actually depicts is a magnetic field ejecting material from the center into the polar regions of the supermassive black hole. And so this was actually an artist rendition there's a lady from NASA that actually made this from an article that I was in like 2016. So yeah, she did that. That's specifically my photo. I see it every now and then on the NASA channels, but that was made for my article.
Very awesome. Okay, a few more questions. So we'll switch now to the SOFIA project. Is it the Sophia Telescope? What's the name of that project?
It's the Sophia Telescope. Yeah, and so SOFIA stands for Stratospheric Observatory for Infrared Astronomy.
You got it. It's right here.
So what that is, it's an airborne telescope. It's 2.5 meters in diameter. And the reason that NASA wants to put a telescope onto an airplane, or even in space, like we just had the JWST that launched into space. Right. The reason that NASA wants to put these telescopes onto airplanes or in space is because the water vapor and just particles in the atmosphere can kind of mess up some of the observations that you want to take in certain wavelengths. So from the ground, we can look in optical, like invisible wavelengths. We can see that through the atmosphere. However, if you want to go to like lower energy wavelengths, we can't necessarily see those. We can't see those wavelengths through the atmosphere, and so we have to get outside of most of the water vapor in order to see that. And so NASA, in order to get these kind of like low energy processes, NASA built this airborne telescope. And it just so happened that the telescope became active in my first year of grad school. And so in my second year of grad school, we started getting data from the telescope. And so this telescope has kind of been the crux of my entire career. And it was just decommissioned literally a few weeks ago. I just got more data in yesterday. I got like my final little bit of data in from this telescope yesterday. And after that, it's being decommissioned.
Are you going to be analyzing that data for like a long time to come?
Hopefully I can get it done pretty quickly. I think I can probably get it done in the next few months. There is some separate data, like there are two forms of data that I have. One is an image, and that can be done pretty quickly. One is a spectrum, and the data analysis for the spectrum might take a little bit longer than just the plain image.
And one question here, this is another North Carolina question. What is the tiniest thing seen by this telescope?
So I actually had to ask a friend of mine this question because I know that she was looking at asteroids within our solar system. So, we can't necessarily look at small objects that are really far away, but we can look at small objects that are really close. And so I know that there are a series of asteroids that are about maybe 3 times the distance from the sun to Earth. It's about 3 times that distance to these asteroids that SOFIA can look at, and we can, or that I say we very broadly, I mean like the scientists that are doing this, they can look at the signatures of these asteroids and figure out what kind of rock these asteroids are made of. And so these asteroids are about maybe 40 miles in diameter. And so that's maybe the distance from like, oh, I guess y'all aren't in Texas.
I know, it's all over.
I was going to give Texas distances, but 40 miles would be
like wherever you can get in 40 minutes.
Yeah, somewhere that you can drive within 40 minutes. For me, it's a town called San Marcos, Texas. It's about the distance from San Antonio to San Marcos.
Okay, so when we go to this question here, this is a team in Texas, Team Red Eagle. How do telescopes tell us the age of distant galaxies?
So that's a really cool question. Because so essentially all of the galaxies were created at around the same time after the Big Bang. But what we can do, instead of telling the age of the galaxy, what we can do is we can tell the age of the universe itself by looking at galaxies. So essentially, like if we look at galaxies that are close to us, we can see that, or we can see in general that all of the galaxies are moving away. But galaxies that are closer to the Milky Way tend to move away a little bit more slowly than galaxies that are further out. Sorry, I'm trying to. This is reversed in
like mirrored, yeah.
So something that's near to us is going to move a little bit slower than something that's further away. It's going to move like a little bit faster. And so we can look at the rate at which galaxies are moving away from us by looking at galaxies that are close by and then looking at galaxies that are really far. And so when you look at that rate of how far they're moving away and how quickly they're moving away, you can kind of extrapolate down to like, well, when were we all in contact? And so that's one way that we can tell the age of the universe by looking at distant galaxies. But the galaxy itself is going to be about the same age as the Milky Way, which is 13 billion years old.
I'm curious, what is a misconception that is like annoying to you that a lot of people think this and you're like, no, that's totally wrong?
Probably the misconception about black holes.
Okay.
That anything can happen inside of a supermassive black hole. And like in the movie Interstellar, where Matthew McConaughey like falls into a black hole and then winds up in a closet. And like that's not what happens in a black hole.
What?
Yes. Did you see Interstellar?
Yes, I love that movie.
Yeah.
But I won't believe anything.
Yeah, but there's a part where he like goes into a black hole and then he ends up, and he's the one that's like shifting the books in the library or something like that. But yeah, so if you fall into a black hole, like it's a place of infinite gravity, so you're just going to get completely smushed. You can't
get transported into a closet.
You don't get transported. You just get smushed.
Oh. I mean, it's their interpretation of it, but I was imagining that they had some kind of consultant that was an astrophysicist, but
I think they did, but I still think that they took some liberties with their story.
It's a movie, Hollywood. Okay, so let's switch to some more fun stuff. I had a question here. This is a team in New York, and this was a class that asked, how do you make time for your hobbies, and what are they?
So it's a good question. I would say that my primary hobby outside of looking at space is, just being outdoors and going hiking and stuff like that. So for me, what I will say is that when I was in grad school, there was no time for hobbies. I didn't have hobbies in grad school. But like once you get into like this being more of a career, then you work like your 9-to-5 job, and you go home and you go for your hikes and stuff like that. For a day like today, for example, I still have a bunch of grading. I'm instructing a couple of classes, and so I have a bunch of grading to do that I haven't gotten done today because I've been lazy. But what I'll probably do is after this call, I'll go stop at the park on my way home, walk around the park, enjoy the outdoors, and then go home and sit down and probably grade papers after that. But yeah, you definitely have to kind of get a break in, like no matter what, you have to get a little bit of a break in from, work and, whatever you do in the evenings or.
Mm-hmm. And what are some of these pictures? Can you tell us about them?
I can. So let's see.
I can point to it.
Which one first?
How about this one down here and you're talking to somebody important?
Okay, so that was actually a really cool experience for me. That was just this past April. So I live in San Antonio, and there are a bunch of Air Force bases here in San Antonio, which for me I think is very cool because I was in the Air Force. And so every 2 years, one of the bases, either Randolph or Lackland, will host an air show. And I don't know if you've been to an air show, or any of the students have ever been to an air show. I'm assuming probably not. But what that means is that the Air Force invites a bunch of people, a bunch of planes onto the base, and people who love airplanes can go and tour around and walk into the airplanes and look at new airplanes, old airplanes, and then they have airplanes that are doing stunts and stuff like that. And so it's just an entire day of airplanes. And so this year at the air show, they did like a STEM expo, and I was in charge of the UTSA astronomy exhibit. And so that is me talking to a general about about UTSA and UTSA astronomy. Yeah.
That's cool.
Mm-hmm.
And this one here, I think, is a eclipse that happened.
Yes. So it's going to. So we're going to see in Texas. We're going to see
23.
two eclipses. I don't know if you knew this.
I didn't actually.
Yeah. So starting a year from tomorrow, actually, October 14th, 2023, 1 year from tomorrow, there's going to be an annular eclipse that comes through Texas. And the largest city in Texas that it'll come through is San Antonio. And then in 2024, we're going to see a total solar eclipse in San Antonio again. And so these two eclipses kind of cross each other right near San Antonio and the Texas Hill Country. And so we're all super excited to see those. And so, I mean, like, we're doing like so much eclipse planning. I'm attending an eclipse workshop next week. We are all things eclipses here in Texas.
So there will be an eclipse party, and I will be joining you.
Yeah, and it's, even in College Station, I think the total solar eclipse might go right through it. I'm not sure. You'd have to look it up.
I'll drive to San Antonio. I'll be there. That sounds cool. And then here, this was the Lucy mission patch. You want to tell us about that?
Yeah, so I got to go. I was invited. I can say that now. I was invited to watch a NASA launch at the Kennedy Space Center in Cape Canaveral. But the funny thing is that it's just completely by happenstance that I got to do this. So back in 2018, so 4 years ago now, there's an institute here called Southwest Research Institute, and they do a lot of the planetary and space sciences, which is kind of how I know a lot about the planetary and space science, stuff like that. So what they do is they send actual missions out to Mars and Jupiter and Saturn, moons and stuff like that. And so one of their missions was called Lucy, and what Lucy is a mission to go to one of the, I'm drawing a blank. It's an asteroid. It's an asteroid that's in the same orbit as Jupiter. That's what it is. Yeah, it's an asteroid in the same orbit as Jupiter. And what they want to do is they want to send a spacecraft there and literally like collect dirt samples from this asteroid, because these asteroids are supposed to be some of the most primitive objects in the entire solar system. And so they can give us information about like how it was formed. And so the mission was named after Lucy, which is the first hominid or first Homo sapien. I'm not sure that was found. And so in order to, I was invited to take a data point back in 2018. And what it entailed was we had to go along some line of latitude that wound up to be in West Texas. And we literally had to stop on the side of the road, which you see depicted here in one of those photos. We had to stop on the side of the road, set up a telescope, wait until exactly like 8:22 p.m., take data for 1 minute, and then pack the telescope back up, put it in the car, and drive the 3 hours back to San Antonio. And so it was just this kind of like a funny little mission that I volunteered to be a part of. But then like a couple of years later, they were like, hey, you took one data point, and so you can attend the NASA launch.
Whoa, cool.
Like behind the scenes, sit on the bleachers, watch the countdown. And I was like, yes, please. And so then the other image you see there is the Lucy mission launching from Cape Canaveral.
That's awesome. Okay, so we are going to end now on some rapid fire questions. And I see the light from your window is like on you. Are you being blinded? Feel free to move. Okay. All right. So for this part, you are just going to come with the first answer that comes to mind. I'm going to give you about 10 seconds for each question.
Okay.
Are you ready?
Yes, I think so.
Okay. Which planet do you find the most fascinating and why?
This might be a lame answer, but Earth. I think Earth is like the coolest place. It's the only place that you can find water. It's the only place where you can, where people can live. And so, to me, everything else is just either too hot or too cold.
We're the perfect place. I love it. What are the biggest challenges of being an astrophysicist?
Learning how to write code. I never wanted to be a computer scientist ever in my life. I am terrible at writing code, but if you're an astrophysicist, you have to learn to write it. And it's kind of like learn as you go.
I did not know that. So coding is also part of astrophysicists.
Because every time you get an image from whatever telescope, you have to be able to manipulate the image. And so you have to write your own code in order to do all of your data analysis. Because nobody's ever done any of this before. Like you're the first one. Like nobody's used that telescope to observe that thing. You're the first one. And so you have to figure out what the best way to analyze that data is. And you do it all through code.
Interesting. Huh. Very cool. If you ever made contact with aliens, what would you tell them?
I would tell them that there is a really cool middle school in California called Anna Kappa Middle School that has a really cool Team Mars Madness.
I love it. Okay, why do I see very few stars at night? And I don't know how big their town is, but they're in North Carolina.
I would assume, so here in San Antonio, it's kind of a big city, and I don't see very many stars at night because there's so much light pollution. So if I go about an hour north, I can look up and I can see so many stars. So I don't know quite where your town is, but it seems to me like it's probably because of light pollution, which is it's actually a really big deal for astronomers. And there's an entire movement, like a dark skies movement, to preserve what dark sky we do have.
And what does that entail? It's like having lights turned off at night?
It's making sure that the places that do exist with dark skies use the proper lighting in order to keep those skies dark. So especially out in West Texas, where the poster is from, I know that they actively try to engage with nearby communities in order to have like proper street lighting. So for example, if you have a light bulb, and I know I'm supposed to only have 10 seconds, but
it's okay. I have to follow
for a
up.
street light, if you have a light bulb, light goes in all directions. But at night, all you need is the light to go downward. And so one way to combat light pollution is to have the proper lighting so that your light goes downward onto the street and doesn't go upward and affect, visibility for telescopes.
Interesting. Okay, and then what was your favorite memory in serving in the Air Force?
Oh gosh, that's a good question. So my final year in the Air Force, I was actually stationed on the island of Crete. So that's an island that belongs to Greece.
Yeah.
So that probably by far has to be my favorite memory, was 1 year living on the island of Crete.
Probably eating baklava and drinking ouzo. I'm Greek, so.
Oh, really?
Yeah.
Cool.
Crete is amazing. I can imagine that must have been fun going to the beach and that's one thing that I tell students is a lot of these different STEM jobs have travel involved. And so if you're interested in and traveling different places. And especially like if you're an astrophysicist, you have to go to places that doesn't have, like you mentioned, that light pollution. Were there other places you've gotten to travel to as part of your job?
Oh, absolutely. So my first, oh, I'll just talk about grad school. The first place that I traveled in grad school, one of the images that you showed was a telescope that's in the Canary Islands, which is off the coast of it belongs to Spain.
This one?
Yeah, that one. Yeah. So I mean I took that photo. So that the island belongs to Spain, but it's off the coast of Morocco. And so you can see behind the telescope, it's clouds. But I mean, like we're on an island. Literally, the island is a mountain, and like they put these telescopes on there. Um, and then one year we went down to Chile for a conference. Actually, next month, some of my collaborators, I don't get to go, but my collaborators are meeting in France. Trying to think of where else I traveled, but I mean, oh, I was going to say that one of my collaborators works at a university in Crete. I haven't visited there or anything, but I do know that, like, I mean, our collaboration is an international collaboration, and so if you want to go to grad school in England or France or Japan or any, Australia or wherever, I mean, you can certainly do that.
Yeah, very cool.
I chose Texas because I was like, no, I want to stay put somewhere.
You
So
were ready to settle down.
yeah.
And that's what's so cool about these jobs is you can kind of pick, right? If you're really interested in traveling, you can have that position where you get to go to different places and take data and meet, interesting people, or stay put and be behind a computer and do coding. Like there's just so many different types of jobs.
Mm-hmm.
All right, we're going to skip through here. Okay, so we're going to wrap things up here with some Space Club highlights. So these are submissions that students have been sending us from all over. There's 2 schools here. One's working on this mission to Mars, and they're making these wearable devices where they use the idea behind circuitry and have to create like these light up things that they wear. And then here are some of their mission patches, which are pretty cute and creative. I like this monkey. Oh, it's like monkey playing soccer and football, perhaps. I don't know.
Oh, cool.
And the mission patches are fun because they're supposed to come up with their spark. So like whatever they're passionate about should be featured on their mission patch. And here's another one. These are from the Colorado Skies Academy doing a mission patch. And it looks like here they are working on their plants in space. So we talk about hydroponics, and they have to design this device. These are bean seeds to like grow something.
That's cool. Like for Mars?
Mm-hmm. Yeah.
Oh, yeah.
Yeah. The final project to design a habitat. So we have to think about like, how would you grow something on the moon or Mars? And then this is fun. We put in all the different mission patches that we got, and you can kind of see the range of interest from the students, and featuring everything from they're interested in space or traveling or video games. And I'm gonna guess this one is video games and basketball. I don't know what the little cross stitching is.
Baseball?
Baseball could be. Yeah, you're right. Oh, this one, my spark is accessorizing. I love it. Or this one's building with Legos. And you said your spark, or the thing you like were passionate about, was just space, right? As a kid.
Yeah, it's kind of cool is that there are a lot of us, astronomers that like to wear a lot of space themed apparel. Mm-hmm. And so you were talking about what's the one down here that you just mentioned?
Oh, this one, Carrie, accessorizing.
Accessorizing, yeah, like space themed accessories would be kind of cool.
Yeah, I got one on.
Oh, cool.
And then we have some here working on this. Team here is doing straw rockets, so they're learning how you launch rockets. And then this one is landing. So first they launch to Mars, and then they have to design this little lander to land their astronauts safely on Mars.
Oh, cool.
And so y'all are doing an awesome job out there. And from all those different teams, we have put everybody together in a raffle. And in honor of having an astrophysicist here on Career Chats, we thought it would be cool to give away a telescope. And so right before we started, I was asking Dr. Fuller what she recommended. So I'm going to make sure y'all get an actually good telescope, right? And I know there will be issues with teams. We talked about light pollution. If they're living in a big city like New York City, having to think about, can you go to like the top of the building? And we can send them tips on like how to actually see stuff out there. Any tips while I switch over to our raffle for like if you have a telescope, how to use it?
Like, I was saying earlier that I'm kind of the telescopes that I use are like really large, and so I'm kind of dumbfounded when it comes to the actual handheld telescopes. I mean, I can point and look, but there's a very specific way that the more professional like astronomers actually use their telescopes, and it's normally if I'm around the astronomers doing like a star party or something like that, I just ask them to take my telescope and set it up for me because it is very specific, like the way that in which you set it up.
Well, we are going to give away one telescope to a lucky school that had a team submit. And I think star parties are the way to go. And so if you get this telescope, I recommend hosting a star party.
For
Look
sure.
up your local astronomical association. They will probably be willing to bring those gigantic telescopes out, bring people like you, to come show off the students.
There's probably an amateur astronomy association in any city.
Yeah. So look it up. If you just Google it, put your name of your town. But now let's see who's going to win. So we're going to spin the wheel and see who our lucky team is. I need some like sound effects here. I'll hear that. All right. Red Eagle from Faith West Academy. Congratulations. You win a telescope for your school. And with that, that wraps up our Space Club Career Chats. And I just want to ask you, Dr. Fuller, first, thank you for joining us and sharing your story and all this like fascinating stuff about astrophysicists and black holes. And it's just like so complex, but cool to learn about. Do you have any final message or words to all the elementary and middle school kids out there watching?
Oh, that's such a good question. Because I mean, if you love space, what's really cool about space right now is like I grew up in the 80s when I was in elementary school and middle school. It was the 80s and 90s. And there weren't very many resources for me to go to. And so there are so many resources now for elementary school, middle school, any age to access. And I have so many in my head. So if anybody ever wants any kind of like resources, I have a ton that I can give you. Like it's at your fingertips and it's so cool. And I'm kind of jealous from being, a child of the 80s and 90s because I never had any of this. I just, watched astronauts and thought that they were like the most amazing people. But now you get to, kind of like log in and have conversations with scientists. And so my advice is, or what I would say is like, use all of these really cool resources that you have now.
And we have a lot of teachers that support Space Club that are running Space Club in their school. So I would love to get the list from you and I can share it to all the teachers. We send out a newsletter and we can get it out there and they can share it with their students. Because we have so many kids out there that are really passionate about space and they hear people like you that are like, go look it up. And it's like, where do I go? Because there's just like, So I appreciate it. Thank you again for being here. And to all the students out there, thanks for tuning in to Space Club Career Chats. And we will see you again next month. So make sure you get your submissions in and maybe your team can win a cool raffle prize. But goodbye for now.